Welcome to this unplanned episode on my E34 BMW M5 because, surprise, surprise, something's gone wrong. For those of you tuning in, this is my 1991 BMW M5 and we did a full build series on it. This thing was purchased for $7,500 US and it was a bit of a beater. We fixed it up, we made it good. And it lasted, 3 drives. And then I had this very annoying tick coming from the front timing chain cover of this engine, and that is a worrisome sign. So I decided to go down the rabbit hole. I figured out, I think, what is wrong with it. We will be doing that work, but then I figured, you know what? If we're gonna do that work, well, we might as well address some other things. I got a new set of wheels and tires because that's what every YouTube video is about. And I'm sure some of you will be very, very happy with them. I also stumbled upon a company called Angry Ass Solutions, and they are doing God's work in the BMW, like classic BMW world. I'm gonna do a short shifter, I think, and I figured out that this car doesn't have catalytic converters, so we will be installing a set from G-Sport. So after doing a ton of research, I have figured out that it's unlikely that we have a stretched chain on this car or we have a timing chain guide failure. What the likely cause of this is, and this further kind of secures that, is the timing chain tensioners are notorious for leaking. You can see there's an absolute ton of oil in this diaphragm. And what it does is on cold start, it ticks and it makes this noise. And if they're bad enough, they'll just tick all the time, which is, I think, what I have going on. I won't know for sure until I replace it. And I figured before we even, go in and try to do any timing chain replacement stuff, let's start with this and replace this. All right, guys, so let's see here if I can loosen this on. You can see it's super tight against this housing. Of course it is. This is a BMW problem. So I think what I got to do is hold this diaphragm in place here while I crack that, and that so far is not going so good.
Not so easy?
No, of course not.
Well, there's probably a special service tool.
Oh yeah.
Designed by Hans and Franz.
Yeah.
So you can hold that and loosen it at the same time.
Well.
Oh, there goes a knuckle.
Well, no knuckle, but it is loose. So here is what I would consider one of the most complicated chain tensioners that I've ever come across. You can see, so this is what actually holds the guide in place. There is a massive spring here. And then there's this diaphragm, like I showed you. You can see it was pouring, or one of these crush washers has failed and is leaking. There's like so many potential points of failure and leaking. You got one crush washer here, you got one here, you got one here, and then I think the diaphragm inside here can fail. So there's a lot. There's a lot that can go wrong here, and I do have a solution for this, which is an updated tensioner. And here is that replacement. This is from an S50 M3 engine, so this would be the Euro spec E36 M3 engine. And essentially, it's just an updated design. You can see much, much simpler. And I would install this right now for you guys. However, you see this crush washer? Guess who forgot to order a crush washer? Next day here, and we do have ourselves a crush washer, which means we can start installing this. And I did read online, there is a trick to install this. As you can see, because this falls in, there is no pressure pushing this out, where the old one had a spring that would like create the tension. The trick here is to fill this up with some oil, which is what I'm gonna do right now. Now, I don't really know how much oil to put in. Oh, there's a hole right there, so this is gonna ooze out. I assume now with the oil in here, if I drop this in, it's either gonna, I assume it's gonna ooze out the side. Yeah, see, it's just, see, it's pumping it out. So after a bit more reading, I think what I need to do is I need to put this, as they call, plug into the hole there, and then come in with this. You can see I filled it up quite a bit with oil, and I've used a little rag here as my plug because there is an area that it would leak out. And so the plan here is I put this in, you can, so there, so now it is on the tensioner, or the plastic rail. Now I come in with this, and I should, this is probably gonna have a ton of oil leak out everywhere.
It's gonna go right in your mouth.
Oh, yeah, I've already pushed it out. Oh yeah, it's leaking everywhere. Oh my God. Well, you can see, okay. So I've overfilled it. Pro tip, don't overfill it like I did. But it is holding it. Now it's just a matter of screwing it in place here. Oh, it's running down my arm DP. It's so bad. It's so bad. Oh, it's going onto my shirt now. Into my shirt. Oh, I'm gonna need a full wardrobe change here. But I am in. Okay, I got to do this quickly, but oh God, that's so gross. And just to be 100% sure that my theory worked, I busted out the Depth borescope here. It's a little Bluetooth camera, you can see, and there it is, guys. Look at that. It has made contact. It is on the chain rail there, so, or the guide, sorry. So we have positive contact. If you guys followed along with the previous build series on this vehicle, you will know that the S38 is actually quite a reliable engine. The main problem with it is its vacuum system. And as expected, when it's 30 years old, things start to fail and fall apart. I did like a quick fix up of just the vacuum lines because I didn't know angry ass solutions existed, and they essentially now have a complete setup. Like Greg, the guy over there, has taken all of the guesswork out of figuring out what you need and has put together packages for you. For example, like this is a vacuum reservoir, and you know, like this filter here, I'm sure there's a BMW part number out there. If you looked far and wide, he has already figured that out. That is what I'm gonna be replacing it with right there, the filter. This is the new hose. The old hose, as you can see, was cracked. I used a little bit of like this rubber tape on it just to seal it up because I didn't have anything. You can see, look at where it was cracked, right? And these are just like so hard and petrified. And the problem is this little leak will make sure that your engine is not running correctly. He's also gone to great lengths to make sure everything looks as OEM as possible. Check out this vacuum hose. This is much like the OEM with like the sheathing around it. It's just incredible. As I said, he's done so much great work. I cannot say better things about him. Like until I found him, I spent so much time like racking my brain trying to figure out how I'm gonna replace this stuff. And he's just like, yep, we've got this, we've got this, we've got that.
It's also come up with the perfect company name for somebody who works on old BMWs.
That is true, because you do have to kind of be angry to work on old BMWs, don't you, DP? And maybe a bit of an ass? right, that completes the entire vacuum system on the plenum here. As you guys just saw, I did also replace this actuator. I had a feeling mine was failing. It wouldn't hold vacuum. And some of the small little details, like look at Greg from Angrias includes this tiny little metal 90-degree transition here. And that is much like the factory. I think the factory uses a plastic one. He's gone to metal. And he also built this entire actuator out because this is an NLA product not available anymore. And you guys saw me replace this whole contraption here. You might be wondering why. If you look closely, I broke this while trying to take it apart. This is a part of the brake booster, and I glued this back together using some JB Weld, and he had a brand new unit, which I wanted because I know this wasn't gonna last forever. So man, the intake system is like fully refreshed, so I'm confident it's gonna work well. I also had Greg order me a brand new throttle cable. Surprisingly, these are still available from BMW. I think they're just a little bit different, but this one here, you can see it's floppy. It was failing. There was just a bunch of like the wire itself, you can see just kind of had like a weird kink in it. Every time it was sitting in here, it looked like it just was not good. So with that tensioner back in, normally I would be putting back this secondary air pump, and I'm going to be replacing it with an air pump delete. This is from Angrias Solutions, and beautifully machined billet piece. And it's just gonna simplify things because that secondary air pump is a big pain in the butt. Greg does include everything to make this a bolt-on and to delete the whole secondary air pump system, which is really, really nice. It even includes a thin wrench so we can tighten this Continental belt, DP.
Oh,
Look
yeah.
at this. Conti Tech, only the best. Greg knows what's up. He's using the best belts.
Is that an extreme contact force belt for maximum grip?
Well, it might as well be at this point, my man. So I'm just gonna finish tightening this thing up and we are gonna be ready to rock here. So some of you mentioned in the previous build series that I should do a valve shim adjustment because these do go out of spec. And I did do exactly that. However, I did this a few weeks ago, so let's cut to the footage of that. I have brought in an expert, Paul. Thank you so much for dedicating the time.
Expert name, right?
Yeah, well, no. You're kind of our local, BMW guru in M5s, I could say, right?
Yeah. So one of the first things you need to know when you're working on older cars that had a really good enthusiast community, and still do especially, is you're going to be stuck using Facebook a lot, and Facebook is great for some things and absolutely a dumpster fire for most things that involve
most things
products.
automotive, yes.
Yeah, so what you need to do is get those dead links that you end up finding through forum posts and things like that when you're searching and make them alive again, because this isn't going to help us do anything. So if you take that and you paste it into this website, which is called archive.org, what it will actually do is show you a list of the snapshots that it's got of that page over the years.
Wow, that's cool.
Sometimes you'll get lucky and sometimes you won't. Sometimes there'll be images and sometimes the snapshot won't have the images loaded. And if that is the case, just go back to an earlier one. So this site's been dead probably for at least 3 years, I'd say. Going back to 2019, we click that and we get a calendar view here and you can see all these little dots. Just hover over one like that and click the snapshot link. It's kind of a clunky interface. So this page loads. It doesn't actually have all the pictures, but the important pieces of information are all here. Not all of this I agree with, which I'm going to correct a little bit of this as we go on.
Well, and that's the beauty of making this video
Exactly,
here.
yeah.
People can refer to this
Yeah.
and refer to this video. And
Right, yeah. So to save me some time, Pete's helpfully taken the valve cover off, as you can see. He's also taken the fan off, which is great because if you come around here, you'll see that we actually have a nice long extension on here, and it's like a breaker bar on the actual crank pulley there. So we can move it around and we can rotate the engine, which we're gonna have to do because each of these camshafts, if you have a look at these, have to be pointed straight up. All right, so for both of these on cylinder one exhausts, we're measuring a very slight amount of drag. It shouldn't pinch. That's why you want the angled feeler gauges. Should be able to slip in there, but you can feel some resistance even when you have it perfectly flat. And then it measures 0.011 or 0.279. We're going to use millimeters here. We're going to round because we're not that crazy, and we're going to write that down on our chart. So
look at this fancy chart we've built out.
cylinder one, exhaust, And that is A and B are the same, which is nice. So I'll just write an A on that and a B on that. And we can put for the lash, which is the distance we just measured, 0.28 for both of these. You don't need to use the shim column unless we have to actually make an adjustment. These are still within spec, so we're not going to have to on this one. So what we've done is our very German spec table here, so we have a really good map of the health of the engine, and the clearances that we're looking for are 0.28 to 0.33. This one here is a good example of a really tight 0.28, and if it really starts to bind, and I'll show you that in a little bit, what the actual feel of the feeler gauge is, you're going to want to err on the side of caution and just label that as a no-go. So we have to change the shims for every single one of these with the red dot, and all the ones that are well within spec and that has a little bit of slop to it, so we have a little bit of room there, should be changed the next time, or checked at least next time. So since we have a lot of them that are on the edge of spec, which is 0.28, you're going to have to check all your valves again, but I do that every time anyway because it's a good snapshot of the engine. So you're not necessarily going to have access to these tools, probably not. These are actually dealership tools. This is a handmade in Romania tool. I'm sure some guy in a workshop literally makes these for BMW. It has an actual part number on there you can see. And then this is a shim kit with all the different types of shims and different sizes you could possibly need. So what you want to do is you want to pick your E for intake in German. I'm not going to pronounce it because I'd get a bunch of people saying I can't speak German, which is true. Make sure you wiggle it in between the two. These are called buckets. You can see that little gap. I'm going to spin that so it's pointing out there and here on this side. And then once you know it's centered, lever it down, it'll hold itself in place. Now what we've been finding though on Pete's engine is that these shims don't want to remove themselves.
Yeah.
What you normally do is you take your little magnet tools, move them around like that. You can also get a little pick tool in that little slot. You can see the slot down there. If you pry that up, it seems like it wants to lift, but because of the oil that Pete's using in this thing, it's just like glued in here. So what we have to use are shop tools, and that involves one of these awesome oil absorbing pads. Place that over top, take your compressed air and shoot the snot out of this thing until it breaks the seal with the oil. That's all that's actually holding it at this point because there's no physical interference with it. There we go.
Success!
Yep. All right, so we're at a 0.385 shim, which if you can see here, I wrote down. That's what we're starting with on the intake. And we're at 0.36, so we're too loose. We want to get this down, which means we have to thicken the shim. So we're going to switch this out for a 3.9. So when you're putting these shims in, when they're brand new, they're going to look like that with writing on both sides. But if you're using a shim that you've already had in an engine, you're going to have a polished side. Keep that toward the camshaft low because that's already got no writing left on it. And you want to be able to see what it is without having to get the calipers out. Let's pop this in, writing side down. Push it in with your finger, it just sits right back there and we're done. We can take the tool and gently lift that down. You can hear the shim.
Much precision.
And then we're gonna actually check it, make sure it still measures what we're expecting. And then tilt it and press it down like that. And that one's just nice and grippy. Perfect.
That's it.
Yeah.
Job done. Man, that's a lot easier than I expected, but having the right tools seems very, very critical in this, right?
If you get stuck with the thick oil that we had, an air compressor is going to be necessary, but I've never had to use one before. So this is an example where you get a little bit of unexpected things pop up.
Well, sweet. Thank you again, Paul, for taking your Sunday out and coming to do this. I certainly appreciate it, and I'm sure this thing is going to run very, very mint when I fire it back up.
Yeah, I'm looking forward to seeing that too.
So the next thing we want to do here is make sure that these butterflies are properly synced together. And huge thanks to Greg at Angry Ass. He sent me, as you can see, this 3D printed mount for the throttle body. He usually makes these out of billet, but he didn't have any in stock, so he made this for me real quick and also provided me with this dial gauge. And to do this properly requires a little bit of effort here, but it's a very simple procedure. Before I get started here, I do need to make sure that the linkages are disconnected and the set screws, the adjustment screw, is fully backed out, because we want to make sure that this plate is sitting at its natural resting place. And now with this zeroed, I'm going to install this, and we do want to add a bit of preload. This thing measures in thousandths of an inch, so I'm going to go to 50. There's a little set screw on the bottom that I'm going to tighten up. Now I'm going to zero out the dial gauge, and I am going to adjust the set screw here while holding the nut. And what I'm looking for is anywhere between 4 to 6 1/1000ths of an inch, and I've been setting them to 4 1/1000ths, so that's about there. We're not done just yet. What we want to make sure now is if this throttle linkage is the right length and doesn't have any type of preload that's opening it up. So now I'm going to zero the dial gauge again, and then install the linkage onto here and see if we have any type of preload. And you can see this one is set correctly because it didn't move at all. We will have to repeat this for, of course, the other two sets, and let's see where we are at with this one, and it is also at 0. Last thing to do is, I forgot to mention this prior to adjusting this, I did loosen up the TPS because you do not want any preload from it. And according to the internet, to set this, you're just listening for the click when you crack the throttle open right away, so you can hear it. So it is set to the right position. That is it, as simple as that. I'll tighten it down, and we, at this point, are mechanically all tuned up. So everything is back together, as you can see, and it is time to do a critical check here first. Watch that actuator. If that actuator moves, then that means we have fixed the whole entire vacuum system. Bam! Which is absolutely huge. Before, the actuator was either the problem or some of the vacuum lines or tubing somewhere in there was an issue. So now everything is working, which is good. We're gonna fire this thing up. Granted, this does not have, right now, we have not done any of the syncing of the throttle bodies through the vacuum. So this may run a little bit rough. Everything is closed off. Let's see how it goes. And listen for that tick. If that tick is gone, that means that tensioner fixed the problem too. Oh man, CP. It's quiet. It is quiet, yes. That means that tensioner, that S50 tensioner fixed the problem there. That is humongous. That means I don't have to take pretty much the motor apart to fix anything on the chain side. And look at that, this thing is actually running fairly decent, man. Here is the DigiSync, which is supposed to be, you know, a good digital tool to sync these throttle bodies. And I've tried unsuccessfully, I think, to get this to work the way I want it to work. It's a little unnerving. You can see it jumps around quite a bit. If you're looking at it right now, this, you know, it should be reading technically like 900 RPM. It doesn't. Not just because of the combustion cycle and the way this works. Ideally, what we want to do is raise the RPM up a little bit, and that will hopefully stabilize this and give us a better number, because right now it's all over the place, and we are just looking for peak numbers. That would really be what we're looking for. So you can see, like 1 second ago, that's showing 170, and this one peak is at 165, 169, so it's 170. So these ones are close, 168, and this one's at 130, 172. So you can see they're all fairly close right now, but they do jump around quite a bit. So it's a bit of a finicky process. So I'm just gonna raise the idle up just a tad, and then we'll see if we can dial this thing in. So as you guys just saw, I dialed in the numbers fairly close around that like 209, 210 number. Every cylinder was almost there. It's hard to know because I just don't trust this digital machine. So what I'm gonna do is pull out a carburetor tune tool here. We'll hook it up and we'll see if the results are the same. And here is the Sync Pro carb tune tool. And you can see, these are popping out, which kind of deflects it a little bit, but it is off. And it's like I'm making a ton of adjustment and it's not doing a ton. Like it's not doing a lot, but that's pretty close. That's pretty close. Final verdict here, inconclusive. I don't know what to trust. As you saw, that carb tool, it was also jumping up around a little bit too much. I'm finding the adjustment is just not there. So it's like there's a very, very small amount of adjustment. I did read online, going down the rabbit hole there, that if you close the throttle bodies a little bit more, then there's more adjustment up top, but I don't even want to do that. I'm just gonna leave it there. I'm gonna drive it around, see how it is. Like the idle is rock solid at 900 RPM. If you guys have any suggestions, how to make this work better or how to do this, the surefire way, certainly post in the comments. And I think that's gonna be a wrap on this episode because we just spent way too much time on this. Make sure to stay tuned for part 2 where we are gonna drive this car. We're gonna finish it up. We're gonna put some fresh new wheels and tires on this vehicle, do a performance chip, and maybe even a short shifter. So we'll see you in the next one.